Alright, so my problem says a sample of CH3COOH is found to contain 80,986 H atoms. What is the mass of this sample of molecules in grams? So in this problem, the info that we are given is that the sample is acetic acid, whose formula is CH3COOH, and the total number of H atoms in all the molecules of acetic acid is 80,986. The problem asks for the mass of all the acetic acid molecules in grams. So it's important to underline atoms and grams because we're beginning in hydrogen atoms and we're trying to end at grams of CH3COOH. To find the total mass, we use three steps. 1. Convert hydrogen atoms into molecules of acetic acid. 2. Convert molecules of acetic acid into moles of acetic acid. And finally, 3. Convert moles of acetic acid into grams of acetic acid. Okay, so for step 1, we start with 80,986 hydrogen atoms. And for every one molecule of acetic acid, there are 4 hydrogen atoms. And a common mistake might be saying there are only 3 hydrogen atoms because of this H3 right here, but you also have to count the one at the end, so there are 4 hydrogen atoms in total. And whenever you put this into your calculator, you end up with 20,246.5, but when you round that to the correct number of significant figures, you get 20,247 molecules of acetic acid. And we know that this unit is correct because you can cross out hydrogen atoms and hydrogen atoms because they're on opposite sides. One's in the numerator and one is in the denominator. So now we have molecules of acetic acid, and we're trying to get to moles of acetic acid. So to do this, we use a conversion factor of 6.022 times 10 to the 23rd molecules of acetic acid. And that is Avogadro's number, 6.022 times 10 to the 23rd. And there's that many molecules in 1 mole of acetic acid. And again, we can cross out the units, molecules of acetic acid, molecules of acetic acid, and we know that leaves us with moles of acetic acid. So this comes out to be 3.3622 times 10 to the negative 20th moles of acetic acid. So now we have moles of acetic acid, and we need to convert those into grams of acetic acid. In order to do this, we will multiply by the molar mass of acetic acid, which will have a unit of grams per mole. And again, you'll see that moles and moles will cancel out, which will leave us with grams of acetic acid, which is the final unit that we'll need to complete the problem. Now, to find the molar mass of acetic acid, we look at the individual atoms in the formula. So the formula again is CH3COOH. And in the formula, we see that there are 2 carbon atoms, there are 4 hydrogen atoms, and there are 2 oxygen atoms. Next, we look on the periodic table to find the molar masses of each individual atom. So we know that carbon is 12.01 grams times 2 because there's 2 carbon atoms, and hydrogen is 1.01 grams times 4 because there's 4 hydrogen atoms, and oxygen is 16.00 times 2 because there's 2 oxygen atoms in the formula CH3COOH. then you multiply these out to get 24.02 grams of carbon, 4.04 grams of hydrogen, and 32.00 grams of oxygen. And then you add all three of these up, which will give you 60.06 grams, which is the molar mass for acetic acid. So now we can clear this, and then we can plug this number into our equation up here. So 60.06 grams per mole, and then you multiply them, which gives you the product of 2.0193 times 10 to the negative 18th grams of acetic acid. And this is your final answer with the unit grams, and we can check back to the original problem and see that grams was in fact what we were trying to get to. Another common mistake is messing up the units in some way, either starting with something other than hydrogen atoms or finishing in something different than grams of acetic acid. So it's important to make sure you get into the correct units, and here is the final answer.